Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about converting between radical form and rational exponent form. In radical form, you're going to have like a square root, cube root, fourth root, and then that little number that's inside of the symbol, like on the outside part, that little V piece is called your index. And if it's within the radical and it's raised to a power, that power is your exponent. And when you change it to rational exponent form, that means you're going to have fractional exponents. And you're always going to put the exponent over the index. All right, so let's use the properties of exponents to convert these rational exponents into either just integers or into radical form. So I have 16 to the 1/2. So it's exponent over index. So my exponent is 1. My index is 2, so if I write this in radical form, the number that's on the outside of my radical in that little V piece is going to be a 2, which means it's a square root. And the number inside is going to be the base 16, and that's going to be raised to the exponent of 1. Well, 16 to the first power is 16, so I'm going to take the square root of 16, and that is 4, which is an integer, so my answer is just 4. All right, the next one I have 27 to the 1/3 power. Okay, so my exponent is 1, my index is 3, so that means it's going to be the cube root, so the 3 is going to go on the outside. 27 is raised to the first power, so it's just 27. And then the cube root of 27, what times what times what gives me 27? Okay, and that is a perfect cube. Okay, so 3 to the 3rd power is 27. All right, 7 to the 3/4 power. So my exponent is 3, and my index is 4. So I'm going to have an index of 4 on the outside, and it's going to be 7 to the 3rd power inside of the radical. So when I do 7 to the 3rd power, 7 times 7 times 7, I get 343. And then if I try to take the 4th root of 343, I don't get a pretty number, so I'm just going to leave it as the 4th root of 343. Okay. The next one, I have 4 to the 3/2 power. So our exponent is 3, my index is 2. So it's going to be the square root of 4 to the 3rd power. 4 to the 3rd power is 4 times 4 times 4, which is 64. And if I take the square root of 64, it equals 8. All right, rational exponent property. So if I have x to the AB, that would be b. Okay, so remember it's exponent over index. So b is going to be your index, a is going to be your exponent. So the b root of x to the a. Okay, and then you could also write it as the b root of x all raised to the a power. Okay, so use the rational exponent property to write equivalent expressions for each of the following radical expressions. So I have the square root of k plus 4. So I can write k to the 1/2 to represent square root of k. The exponent is 1, the index is 2. Okay, and then for this one, I have b minus 7 within the radical, and it's being raised to the first power, so my index is, or my exponent is 1, and it's the cube root, so my index is 3, so it's all raised to the 1/3. All right, the cube root of y. My exponent is 1, my index is 3, exponent over index, so it's going to be y to the 1/3. Okay, this one, I have g plus 4 within the radical, and it's a 5th root, and it's all to the first power, so it's going to be 1/5 raised to the 1/5. So g plus 4 raised to the 1/5, and then I'm just going to bring down that minus 2. So I'm just rewriting them, and they're still equivalent, they just look different. All right, match each of the following to its equivalent expression. So the square root of x plus 5. So the index is 2, the exponent is 1, so I can take x plus 5 and raise that whole thing to the 1/2 power. Okay, and if you notice, these all kind of are the radical ones where I have the square root signs, so they're all square roots. So I'm going to take those and change them into rational exponents. So I know I'm going to match them up with either 2, 3, or 4. Okay, so if I just look at those options, then I have x to the 5th raised to the 1/2, so that one's going to match. And then I'm going to go to the next radical, so the square root of 5x. So I'm going to have everything inside that square root raised to the 1/2 power. Anytime you're just taking a square root, nothing's raised to any powers. It's going to be always to the 1/2 when you convert it. So it's going to be 5x raised to the 1/2. And then I have the square root of x plus 5. So it's going to be x to the 1/2 plus 5. All right, so now I'm going to move on to the ones that are written as rational exponents. So 5 to the 1/3 power. My exponent is 1. My index is 3, so it's going to be a cube root of 5. The next one, I have 5 to the 1/2. My exponent is 1, and my index is 2, so it's going to be a square root of 5. And you don't need to put the 2 for the square root as the index. And then the next one, I have 5 to the 2/3. My exponent is 2, and my index is 3, so it's going to be the cube root of 5 squared. Well, 5 squared is 5 times 5, which is 25, so it's the cube root of 25. All right, so that's it.